This is Apollo Saturn Launch Control. We're T-minus 1 hour, 22 minutes and counting. Cabin purge has now been completed and the boost protective cover has been closed. The 65% nitrogen, 35% oxygen mixture will now be enriched to a 60-40 mixture at liftoff. Just completed were some pre-flight command tests with the Manned Spacecraft Center in Houston. These tests are to ensure that Houston can send commands and that they are being received by the launch vehicle. Also just completed was a first motion signal. This is the first motion of the vehicle as it lifts off the pad. A test signal was sent to the Eastern Test Range and to the Manned Spacecraft Center in Houston to assure that they will get this signal at liftoff. Also, we just received a final go for the Gym-Sphere release. The Gym-Sphere is a weather balloon, which is the final weather balloon to go up before launch, indicating the wind direction. C-band beacons are in check at this time. The C-band beacons aboard the launch vehicle are used in tracking. They give indications of range, velocity during the powered phase of flight. Cue-ball sim command was just sent. The cue-ball is an angle of attack meter, which is perched above the launch escape system, and it's read by the spacecraft commander in the spacecraft. It would indicate any deviation from the planned flight route. It reads 0 as it sits on the pad, and during the test, a simulated command is sent to it, and Gene Cernan in the spacecraft reads off what he is reading in the spacecraft during that sim command. The checks in the spacecraft continue to run somewhat ahead of schedule. The spacecraft test conductor, Skip Chauvin, indicated they're running ahead and looking good, to which Cernan replied, "We're looking good up here too." The countdown continuing to move along well at this time. T-minus 1 hour, 21 minutes and counting. This is Kennedy Launch Control. Apollo Saturn Launch Control. We're T-minus 1 hour, 12 minutes and counting. At this time, Spacecraft Commander Gene Cernan and the spacecraft test conductor, Skip Chauvin, are going over some command checks. During these checks, the spacecraft commander actually gimbals swings the main engine in the service module. He does this using his flight hand controller, and this is a system which is done so that if there is a problem with a computer, which normally flies these, he could take over and manually fly it. Normally, however, all burns of this engine are done by the computer. Out at the pad, the space vehicle is surrounded by searchlights, producing some 225 foot candles of light. A total of 72 20-kilowatt xenon lights and two 60-kilowatt xenon searchlight banks provide this illumination. At liftoff, approximately 7,500 foot candles will be produced from the flame of the Saturn V first stage engines. This is almost equivalent to daylight. Searchlights will also illuminate the Apollo 17 for the first 60 feet of its flight. Our countdown continuing to go smoothly now as we approach the 1 hour mark. T-minus 1 hour, 11 minutes and counting. This is Kennedy Launch Control. Go ahead. This is Apollo Saturn Launch Control. We're T-minus 1 hour and counting. T-minus 1 hour and counting. Just completed were the C-band beacon checks. These are checks of the beacon, 2 of them aboard the instrument unit of the space vehicle. These are used in conjunction with a C-band radar here at Kennedy Space Center to check the space vehicle during the powered phase of flight. Check was just made with the Superintendent of Range Operations, who ran through the camera coverage, looking at the weather around the various areas to see what camera coverage, and that appears to be satisfactory. Meanwhile, at the pad, the closeout crew has completed securing the White Room area, and they are clearing the pad area themselves at this time. Just before they left, they indicated to Cernan they were completed their jobs going back away from the pad area. Cernan said, "We'll see you when we get back." The pad leader responded that the next face you see better be a frogman or you're in trouble. Weather appears to be satisfactory. We've been tracking some local buildups, but at this time they do not seem to be posing any problem for an on-time launch at 9:53 p.m. Eastern Standard Time. Now T-minus 59 minutes, 32 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're at T-minus 55 minutes, 54 seconds, and counting. Stony, astronaut Bob Parker, the capsule communicator here in the firing room, who has a variety of functions during this mission, one of which is to set the elevators at the 320-foot level. He actually commands the elevators, which are part of the egress system, emergency egress system for the astronauts. He has just reported that the elevators have now been set at the 320-foot level. In an emergency, the crew could come out of their spacecraft, enter these elevators where they would be lowered at a high speed, 600 feet per minute, to the ground floor or A-level floor, where they can exit from there into a variety of escape modes, one of which would be down a chute into a blast danger area or a safety area, or they could continue on out and be picked up by armored carriers. Underway at this time with the launch vehicle are some checks of the secure range safety systems aboard the vehicle. These are actually checks of the receivers in that system. A range safety officer could terminate the flight of Apollo 17 if it became erratic by initiating the emergency cutoff, or if necessary, a propellant dispersion command. These systems are located on each of the flight stages, or 3 stages of the Saturn V, 2 receivers in each stage, and they would receive a signal from the range safety officers, and then sending through these receivers, they could perform the propellant dispersion. These actions, of course, would be taken only if the vehicle were so erratic that it were endangering some land areas, and of course only after the crew had used one of the escape options open to them. Test going well at this time. Our countdown continuing. T-minus 54 minutes, 6 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 50 minutes, 55 seconds, and counting. Preparations are underway in the Launch Control Center at this time for a critical power transfer test. The space vehicle at this time is being fed from an external power source, but shortly before liftoff, it will be transferred to the internal flight batteries. This test is to ensure that all electrical systems aboard the vehicle function properly on the internal flight batteries. The test takes about 5 minutes, during which time the various elements of the launch team monitor their systems and report in then to the test supervisor, Bill Schick, here in the control room, that everything looks good during the test. Depending on local weather conditions in various areas around the United States, the flight of Apollo 17 will be monitored or be able to be seen by people as far as 500 miles away. This is the flight as seen of the first stage of powered flight. This would include a large portion of the southeastern United States, northern tip of Cuba, and the Bahama Islands. The power transfer test now underway. First stage, second stage, third stage, instrument unit now all going to internal power. Countdown continuing to go well. T-minus 49 minutes, 35 seconds and counting. This is Kennedy Test Control. Apollo Saturn Launch Control. We're now T-minus 45 minutes, 55 seconds, and counting. Various elements of the launch team reporting into Test Supervisor Bill Schick that they experienced no problems during the power transfer. We've now transferred back again to an external power source, which will feed the vehicle systems until approximately 50 seconds before liftoff, at which time the final power transfer to internal takes place. At the T-minus 45 minute mark, we'll be watching for swing arm number 9. That's the swing arm that gives access to the spacecraft to swing back to a retract position 12 degrees back from the spacecraft. This is a park position, a standby position, where it will remain down till the final moments of the countdown. T-minus 5 minutes, it swings back to the full retract position. Once it swings back, the launch escape system aboard the top of the spacecraft can be armed, and this system could be used to pull the astronaut crew to safety in any disaster. Now, T-minus 44 minutes, 52 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're T-minus 40 minutes, 51 seconds, and counting. Swing arm number 9 just retracted a few minutes ago. As it retracted, the astronaut crew aboard the space field could feel it moving away from the spacecraft. Eugene Cernan, spacecraft commander, commented, "We're really hanging out here in the breeze now." Spacecraft test conductor, referring to the weather, indicated that that was just a small breeze. The launch escape system has been armed. This system now could be used to carry the astronauts to safety if necessary. It's also used during the initial phases of powered flight to carry the astronauts away in an emergency. It would fly away in a high arc, pulling them to a height enough so that their parachute system could deploy and they could make a normal landing. The system is about 33 feet long. The motor develops 147,000 pounds of thrust. This is almost twice the amount of thrust of the Redstone rocket, which powered astronaut Alan Shepard, America's first man into space. The countdown continuing to move along smoothly now. T-minus 39 minutes, 36 seconds and counting. This is Kennedy Launch Control. This Apollo Saturn Launch Control. We're T-minus 35 minutes, 11 seconds, and counting. Spacecraft Commander Gene Cernan just reported back to the spacecraft test conductor, Skip Chauvin. He said, "You've delivered us the best. Now it's our turn. Thank the guys. We want to see them as soon as we can when we get back, and I guarantee you we'll do that." Meanwhile, C-band beacon checks are going on with the space vehicle. The liquid hydrogen, liquid oxygen fully aboard and being replenished at this time to ensure a full load at liftoff. Countdown continuing to go smoothly as we approach the half-hour mark. T-minus 34 minutes, 34 seconds and counting. This is Kennedy Launch Control. Apollo Saturn launch control, T-minus 30 minutes, 54 seconds, and counting. Manned spacecraft just indicated to the test supervisor, Bill Schick, that we are go for the terminal countdown sequences. Final propulsion checks have been completed, and the C-band readouts, once again repeated, have been completed. Beach Boss reports the launch site recovery force helicopters are on station and ready. Digital range safety command checks are now underway as the countdown continues smoothly, aiming for the T-minus 30-minute mark. Now T-minus 30 minutes, 24 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 25 minutes, 54 seconds, and counting. Command Module pilot Ron Evans at this time has armed the reaction control system aboard the service module. He does this by allowing the hypergolic fuels to move down the lines to the engines. At this time, he's reading out the temperatures, pressures, and fuel quantities in that system. Our weather continues to look good. The major frontal area, which had been of some concern earlier, has remained well west of the launch area. Also, some smaller buildups, which we have been monitoring, do not appear to be coming close enough to cause any concern for our 9:53 p.m. launch time. That launch will be aiming Apollo 17 for the Taurus-Littrow area of the moon. This area named after the Taurus Mountains, these in southern Turkey, and the Austrian astronomer Littrow. The site is expected to yield some of the oldest and some of the youngest lunar samples returned during the Apollo flights to the moon. Now T-minus 24 minutes, 50 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 20 minutes, 55 seconds, and counting. A short time from now, we'll begin chilling the propulsion systems aboard the second and third stage of the Saturn V vehicle. This is necessary to condition them for the flow of the super cold liquid oxygen and liquid hydrogen. Just a few moments ago, the crew aboard the spacecraft America was given an updated weather forecast. Cernan reported, "I hope it's as beautiful out there as it is in here." Countdown continuing to move smoothly at T-minus 20 minutes, 24 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. T-minus 15 minutes, 52 seconds, and counting. The Vice President of the United States, Spiro Agnew, has entered the Launch Control Center now. He'll observe the final portions of the countdown from here and also the launch. Arming and checking of the service module reaction control system has now been completed, and in progress is the chill down of the S2 or second stage start tanks. Checkouts continuing to go well, some running a little bit ahead of schedule, all on time. T-minus 15 minutes, 20 seconds and counting. This is Kennedy Test Control. This is Apollo Saturn Launch Control, T-minus 10 minutes, 55 seconds and counting. This time, some computer checks being run with the launch vehicle. The spacecraft has now gone to full internal power. Up to this point, the spacecraft fuel cells had been sharing the power load with an external source. Also going on at this time are some checks of the Astrocom circuit. This is the circuit which is used by the launch operations manager, spacecraft test conductor, Stoney, and the 3 astronauts at launch time. This to ensure that they are not getting any extraneous voices or having to listen to any of the other networks which might be carrying on conversations which they don't need at that time. Countdown proceeding smoothly, T-minus 10 minutes, 15 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 8 minutes and counting. T-minus 8 minutes and counting. The Vice President in the firing room at the Launch Control Center, observing the final minutes of the countdown, and he'll watch the launch from here. The countdown has proceeded smoothly, picking up at 11:53 a.m. this morning. Our weather continues to look good as we aim toward a 9:53 p.m. Eastern Standard Time launch. Now T-minus 7 minutes, 37 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 5 minutes, 54 seconds and counting. At this time, entering the final phases of the countdown, various elements of the team reporting into Test Supervisor Bill Schick with their go, no-goes for launch. At launch time, a water deluge system at the pad will spray water over the entire area of the pad, some 400,000 gallons of water, more than an average family would use in 3 years, will be spread over the pad and the swing arms, protecting them from the searing flames of the Saturn V first stage. Various elements reporting in now. First stage reporting they are go. Range safety, Superintendent of Range Operations, they are go. Launch Operations Manager reports he is go for launch. Launch Director Walter Caprian has given a go for launch. We passed the 5-minute mark, T-minus 4 minutes, 55 seconds and counting, and swing arm number 9 now coming back to the fully retracted position. The launch escape system sitting atop the spacecraft named America by the crew, now could pull the crew to safety if there were any problems while the vehicle remains on the pad or during the early portions of the flight. At the T-minus 4-minute mark, we'll be standing by for a word from the launch vehicle test conductor, Norm Carlson, giving a clear for launch for the launch vehicle ignition. At T-minus 3 minutes, 7 seconds, we'll go on an automatic sequencer. This is called the terminal countdown sequencer. The astronauts on the Astrocom circuit now, reporting and thanking the launch team for all their prayers and all their help. T-minus 3 minutes, 55 seconds and counting. Apollo 17, the launch team wishes you good luck and Godspeed, reports the Launch Operations Manager over the Astrocom circuit. T-minus 3 minutes, 40 seconds, the countdown continuing to go along smoothly. Once we go on the terminal countdown sequencer, the count will be automatic from there on out. The countdown sequencer will initiate the various functions from that time on. However, the men here in the firing room will be monitoring their consoles, watching temperatures, pressures, various readouts. They could override that terminal sequencer if necessary. Moving up now to the time when we'll go on that terminal sequencer, T-minus 3 minutes, 10 seconds, and counting. Spacecraft ready light has come on, indicating that the spacecraft is ready. We are now on the terminal sequencer. Launch sequence has started. Flowing of that water on the pad will begin at the 1-minute mark. Flowing on the flame deflector below the launch vehicle, on the launch pedestal itself, and along the swing arms, which will be coming back at liftoff. Instrument unit ready light has come on. Emergency detection system ready light is on. All indications are we are go for launch as we approach the 2-minute, 30-second mark. Pressurization of the various propellant tanks now aboard the space vehicle is starting. S2 or second stage liquid oxygen tanks now pressurized. These propellant tanks are pressurized with helium to ensure that during the flight the fuel flows properly down through the engines. It's quiet here in the firing room now as the men are monitoring their consoles, looking at the temperatures, checking pressures and a variety of parameters to ensure everything is in a go condition. Pressurization continuing on the fuel tanks. At this time, we'll go to the critical power transfer at the T-minus 50-second mark in the countdown. At that time, we'll transfer external power source to the flight batteries aboard the space vehicle. The final action by the crew aboard the spacecraft America will be a final guidance alignment. This conducted by the spacecraft commander, Gene Cernan. The flight of Apollo 17 will be able to be seen, depending on weather conditions, some 500 miles away as it goes into Earth orbit. Pressurization continuing. Liquid hydrogen tanks now aboard the second stage have been pressurized. All propellants aboard the second stage now pressurized. A cover aboard the cue ball. This is the cue ball system on top of the launch escape system, will be pulled off just shortly before launch. First stage propellant tanks have been pressurized, now past the 1 minute mark, and we are going on internal power. Now all systems to internal power. We'll be looking for the engine start sequence at the 8.9 second mark in the countdown. The engines will build up to a thrust of 7.6 million pounds. T-minus 30 seconds. We have a cutoff. We have a cutoff at T-minus 30 seconds. We're standing by at T-minus 30-second mark. We'll bring word to you just as soon as we get it. We have a cutoff at T-minus 30 seconds. T-minus 30 seconds and holding. This is Kennedy Launch Control. This Apollo Saturn Launch Control, we're holding at the 30-second mark. This was an automatic cutoff, cut off by the terminal sequencer. As mentioned, this sequencer initiates various actions. Each action must take place and must be completed before the next one can be initiated. If anything does not get completed in time, there will be an automatic cutoff. This cutoff was automatic, done by the sequencer. We're standing by now to check just what the problem was. Now T-minus 30 seconds and holding. This is Kennedy Launch Control. This Apollo Saturn Launch Control, the astronaut crew aboard the spacecraft going through their various safing now, safing of all systems, and the launch team here continuing through their emergency procedures. We'll be standing by to check out the problem just as soon as we can get word. T-minus 30 seconds and holding. This is Kennedy Launch Control. This Apollo Saturn launch control, the safing procedures continuing at this time. Up to the T-minus 30-second mark, the countdown had been proceeding smoothly. Weather conditions at launch were predicted to be and appeared to be good at that time. However, we had an automatic cutoff from the terminal countdown sequencer, and we're standing by to see just what caused that automatic cutoff. All systems being safed at this time. T-minus 30 seconds, and we are in a hold. This is Kennedy Launch Control. This Apollo Saturn launch control, we're continuing in our hold at the 30-second mark while the launch team assesses our problem. The swing arm number 9, will be brought back to its park position, which is 12 degrees back from the space vehicle. Continuing the safing procedures this time and assessing the problem, holding at T-minus 30 seconds. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're continuing our hold at the T-minus 30-second mark as the launch team assesses our problem. At this time, swing arm number 9 is going back to the 12-degree park position. This is in a position about 15 to 20 feet from the spacecraft. All safing procedures have proceeded normally. We're continuing our hold while we assess the problem at T-minus 30 seconds. This is Kennedy Launch Control. This Apollo Saturn Launch Control, the swing arm number 9 is now back to that retract position at the 12-degree position. Point out that the window we have tonight extends to 1:31 a.m. So we have some time here to assess the problem and then recycle and continue our countdown. We're continuing to hold at the 30-second mark at this time. T-minus 30 seconds and holding. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're at T-minus 30 seconds and continuing our hold. The problem was with the terminal countdown sequencer, which failed to give the command to pressurize the third stage LOX tank. The crew in the firing room, realizing this or seeing this happen, pressurized the tank manually, but this did not happen fast enough to satisfy the automatic sequencer. As was mentioned earlier, during this sequence, everything must happen at a certain time before the next step in the sequence can take place. The next step that was to take place was the retraction of swing arm 9, and at the time that was to take place, the terminal sequencer had not had an indication that the third stage lock tanks had been pressurized. The plan now is to recycle to the T-minus 22-minute mark in the countdown. Now, this recycling procedure will take an additional 35 to 40 minutes. This still puts us well within our launch window. While we're recycling, we'll continue to review the data to determine just what the problem is and whether or not we can proceed from the T-minus 22-minute mark for a launch later in the window. The crew aboard the spacecraft has been alerted to the problem and understand what is happening. They're standing by there at this time. Now, T-minus 30 seconds and holding. This is Kennedy Launch Control. This Apollo Saturn launch control, we're remaining still in the T-minus 30-second mark. We'll remain here for some period. It will take approximately 35 to 40 minutes to recycle back to T-minus 22 minutes, where we'll resume the count. To explain again, what had happened was we were in what was called the terminal countdown sequencer. At 3 minutes, 7 seconds in the countdown, we go on to an automatic system called a terminal countdown sequencer. This countdown sequencer initiates various actions, the final actions in the count. Each of these must occur on schedule and in sequence. Now, what happened at this particular time was the third stage liquid oxygen tank was not automatically pressurized as it should have been. The launch crew here in the firing room, when they saw this, manually pressurized that system, but it was too late to satisfy the sequencer. The next event in the sequence was the retraction of swing arm number 1, swing arm going over to the first stage, and at that time the sequencer did not see that the tank had been pressurized and sent an automatic cutoff. So we had an automatic cutoff at the 30-second mark. We're standing by at the 30-second mark to go back to T-minus 22 minutes, and we are reevaluating the problem, looking at what caused the sequencer not to automatically pressurize that tank, seeing what that problem is, and seeing if there's a possibility, if we go ahead and do this manually early in the sequence, if that will satisfy the sequencer, and we can proceed. Now holding at the T-minus 30-second mark in our countdown, this is Kennedy Launch Control. This Apollo Saturn Launch Control, we're continuing to stand by here at the T-minus 30-second mark in the countdown. The crew remaining perfectly calm in their spacecraft. They've gone through their safing checks. The various safing checks of the launch vehicle have been completed. We're now going through preparations for recycling to the T-minus 22-minute mark. Standing by at this time at T-minus 30 seconds. T-minus 30 seconds and holding in the countdown for Apollo 17. This is Kennedy Launch Control. This Apollo Saturn Launch Control, we're continuing our hold at the 30-second mark. We'll recycle to the T-minus 22-minute mark. The T-minus 22-minute mark is chosen as the recycling point because this is a point where we start the chill down, as was mentioned during that point in the countdown. We start the chill down of the second and third stages to prepare them for the influx of the liquid hydrogen, the cold liquid hydrogen, and the cold liquid oxygen. This chill down has some very specific parameters and must be started at a certain time and cannot go beyond a certain time. So it's best to go back to that point in the countdown under these circumstances and resume our count at the T-minus 22-minute mark when a determination is made that we can resume. Continuing to look at the data here to see exactly what happened. There is no indication of ignition. Ignition was scheduled to come at the 8.9-second mark. Here in the control room, a number of the people were looking through the remote cameras, which have the capability out at the pad of zooming in on specific areas, and a number of people here were looking right at those first stage engines and there was no indication whatsoever of engine ignition. We're continuing to evaluate all the data at this time as we hold at the T-minus 30-second mark. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, still in our hold at the 30-second mark. While the launch team here is busy recycling to the T-minus 22-minute mark, the mission team out at the Manned Spacecraft Center also pre-planning some of the new times for the mission. They're also this time busily pre-planning the new launch azimuth. The azimuth now, if we go at the next opportunity, would be 81.06 degrees. This will be automatically fed into the instrument unit of the Saturn V vehicle from the Manned Spacecraft Center. All elements of the launch team now putting everything together, checking over data, and doing their best to put us back into a recycle position, ready to pick up the count at the T-minus 22-minute mark. Still evaluating data, however, and we have not at this time been given a go for that resuming of the count. T-minus 30 seconds and holding at this time. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, continuing our hold at the 30-second mark. Back at the Mission Control Center in Houston, the flight controllers returning to their seats now after some consultations. They're back now giving a status check and getting ready in case it is determined that we can pick up the count. In the firing room here, the Apollo Program Director, Rocco Petrone, has moved into the viewing area where the Vice President Spiro Agnew and NASA Administrator James Fletcher are, and he's giving them a briefing and a rundown on our problem. We're standing by at this time. The clock has now been recycled to the T-minus 22-minute mark. However, we have not picked up the count at that mark, but we are now at T-minus 22 minutes and holding. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're continuing to stand by at the T-minus 22-minute mark in the countdown. Recycling operations have gone well. We're back at the T-minus 22-minute mark, and it's at this mark which we would pick up the count if we are given a go to resume. Check has been made of the Mission Control Center team. It's Mission Control Center in Houston. All elements of that team reporting that they are ready to resume as soon as they get the word. Now standing by here at Kennedy Space Center while data is reviewed, and determination will be made if and when we can resume our countdown for Apollo 17. Now T-minus 22 minutes and holding. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're continuing to stand by at the T-minus 22-minute mark. We're hoping to resume the count shortly. The problem has not been resolved. We're continuing to look into it. However, it has been determined that a resolution one way or the other should be able to be made shortly. So right now we are continuing our recycle procedures, hoping to pick up the count perhaps just minutes from now. If the problem is not resolved by the time we reach the T-minus 8-minute mark, after we continue to count down, the clock will be held again. Right now we're continuing the recycling procedures, hoping to pick up shortly at T-minus 22 minutes. We're now T-minus 22 minutes and holding. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're continuing to stand by at the T-minus 22-minute mark. We've been given the word here in the firing room now that the count will be resumed at 11 p.m. at T-minus 22 minutes. At this time, there has still not been a resolution to the problem, but we'll continue looking at that. We could continue on counting down while this problem is looked at. To reiterate what the problem was, the terminal countdown sequencer failed to give the command to pressurize the third stage liquid oxygen tanks. The crews monitoring this function saw that happened and immediately manually pressurized the tanks, but this did not occur in time in the sequence, and when swing arm 1 was to retract, it had not received this signal. As a consequence, an automatic cutoff was sent. There are several possible workarounds to this. They're being looked into at this time, and we plan to resume our countdown at the T-minus 22-minute mark at 11 p.m. Now holding at T-minus 22 minutes, this is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're at T-minus 21 minutes, 10 seconds, and counting. The countdown picked up. The launch team here made a quick check of the various elements, all reporting into the test supervisor, Bill Schick, indicating that they were ready to resume the count. Now counting at T-minus 20 minutes, 53 seconds, and we'll continue to count down here as we look at the problem which caused the hold at the T-minus 30-second mark. Now T-minus 20 minutes, 42 seconds, and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're at T-minus 14 minutes, 35 seconds, and counting in our countdown for Apollo 17. Back at the Mission Control Center, the men there are updating the launch azimuth. Launch azimuth standing now at 82.54 degrees. This will automatically be fed into the instrument unit. The swing arm number 9, the access arm to the spacecraft, remains at the 12-degree position. It will remain there until the T-minus 5-minute mark in the countdown. Going on at this time are the cycling of some of the vents for the liquid hydrogen and the liquid oxygen. These are the vents which allow the venting of these gases as there is some boil-off occurring. It's necessary to continue venting these to ensure that they do not freeze in either an open or a closed position. The countdown proceeding smoothly now, T-minus 13 minutes, 43 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're at T-minus 9 minutes, 36 seconds, and we are counting. However, we do plan to continue the hold at the T-minus 8-minute mark. We can hold at that point for 20 minutes and plan a 20-minute hold while the launch crew here satisfies themselves that they have worked out a good solution and a workaround to the problem. The crew has been alerted aboard the spacecraft. Cernan indicated that perhaps they could start a nice conversation about a good book, Thomas Hardy or something like that. Countdown continuing now, aiming toward the 8-minute mark, at which time we'll hold T-minus 9 minutes now, T-minus 9 minutes and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're now holding at the 8-minute mark as planned. The hold at this time is planned for approximately 20 minutes. The crew feels that they have a workaround to the problem, working around the indication going to the terminal sequencer that the tank has not been pressurized when actually it had been done manually. They are checking all of their data, however, to ensure that this is the proper method to work around the problem and that this will result in a smooth countdown from here on. Now T-minus 8 minutes and holding. This is Kennedy Launch Control. This Apollo Saturn Launch Control, we're continuing our hold at the 8-minute mark. The launch operations manager has gone over with the launch team their proposed solution, a workaround. The team appears to be satisfied that it is the proper one. They are now briefing management personnel on the problem and the workaround. Out at the pad, the liquid oxygen continues to vent from the vehicle and is replenished. Liquid hydrogen is also vented from the vehicle as there is some boil off. However, because it is quite a volatile fuel, it's vented to a burn pond at the side of the pad. That burn pond is at the north side of the pad, and there it can be seen burning in a controlled condition at this time. This is a normal condition. Actually, during the day, this burns in such a pure manner that it cannot be seen. However, at night, it is clearly visible. Our countdown continuing to hold at the T-minus 8-minute mark at this time. T-minus 8 minutes and holding. This is Kennedy Launch Control. This Apollo Saturn Launch Control, we're continuing to hold at the T-minus 8-minute mark. Meantime, the crew is getting a variety of updates in the spacecraft, updating them on various aspects and the changes to their mission due to this hold period. Also at the Manned Spacecraft Center, they're continuing to update the flight azimuth as they get new times for the launch. Launch Operations Manager Paul Donnelly just went through quite an extensive briefing with the spacecraft test conductor to pass on to the crew what they feel the problems were and how they plan to work around it. The crew aboard the spacecraft indicated that if the launch team was satisfied with these solutions, they certainly were confident themselves. Now, continuing our hold at the T-minus 8-minute mark, this is Kennedy Test Control. This Apollo Saturn Launch Control, we're continuing in our hold at the T-minus 8-minute mark. At this time, it's been determined to take an additional 20 minutes, add an additional 20 minutes to that planned hold period. The reason for this is the crews would like to take the workaround that they have devised, and at Marshall Space Flight Center, where the Saturn V launch vehicle was developed, they have what is called a breadboard, or a system which is similar to this one, and run through the sequence and ensure that it does operate properly. The crew aboard the spacecraft was informed of this additional 20-minute hold. They indicated that they expected to use all three stages of this Saturn V, and they were happy to have the 20-minute hold if that was going to assure that all three were going to work properly. Now, continuing our hold at the T-minus 8-minute mark, this is Kennedy Launch Control. This Apollo Saturn Test Control, we're continuing our hold at the T-minus 8-minute mark. The reason the T-minus 8-minute mark is chosen for this hold, as mentioned earlier, has to do with the chill down of the thrust chambers in the S2 or second stage and the third stage. Both of these stages use liquid hydrogen, an extremely cold or cryogenic fuel, and the thrust chamber must be conditioned prior to flight so that it's ready at the time of ignition in flight to receive these fuels coming in. To achieve the proper temperature, the thrust chamber chill down should not exceed 20 minutes, but it must be on for at least 7 minutes and 40 seconds. So rounding that off, the hold was called at the 8-minute mark. We can continuously hold it at this point, whereas if we continued on down, we would have to watch these parameters very closely so that we did not exceed that 20-minute accumulated cooling time. At this point, we can continue our hold, and that continuation can be determined by the problem, and we can pick up then at any time or continue as long as necessary. We're continuing that hold now, T-minus 8 minutes and holding. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're continuing in our hold at the T-minus 8-minute mark. Back at the Marshall Space Flight Center in Huntsville, Alabama, crews there are at work on a breadboard or a mock-up of the system in question, where they're putting it through its paces, checking out the workaround solution that is jumping around this erroneous signal, and ensuring that everything works properly. The crew still standing by in the spacecraft, updating various systems there, updating their flight plan, all continuing to go well there. The crew at the Manned Spacecraft Center also doing considerable amount of updating. They'll be continuing to update the azimuth, and the Launch Control Center here at Kennedy Space Center. The launch team manning their consoles, standing by to pick up the count when we're given the word to go. However, we're standing by still at this time. We have no word from the Marshall Space Flight Center. We're expecting that to come within 10 to 15 minutes from this time. Now T-minus 8 minutes and holding. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're continuing in our hold period at this time. Test Supervisor Bill Schick just announced here in the firing room that the hold is expected to last approximately 20 more minutes. Liquid oxygen and liquid hydrogen continue to be replenished aboard the 3 stages of the launch vehicle at this time. That replenishing will continue during the hold period and during the final minutes of the countdown. Countdown continuing in the hold, T-minus 8 minutes and holding. This is Kennedy Launch Control. This is Apollo Saturn Launch Control at 1 minute to midnight. 1 minute to midnight, we're continuing to hold at the T-minus 8-minute mark. Work still going on at the Marshall Space Flight Center in Huntsville, Alabama. Updating of the tracking, continuing at the Manned Spacecraft Center in Houston, and the launch team here at Kennedy Space Center preparing to pick up the count. Hopefully we'll be given a go-ahead to pick up the count in approximately 10 to 12 minutes from this time. We're continuing to stand by, waiting to hear from the testing going on at the Marshall Space Flight Center in Huntsville. To recap the activities earlier today, the countdown picked up at 11:53 a.m. after a planned hold period, picked up at the T-minus 9-hour mark. Shortly after that time, the pad was cleared, and we began loading the cryogenic fuels, that's the liquid hydrogen and the liquid oxygen, aboard the space vehicle. Those operations actually went a little bit ahead of schedule. The astronaut crew went out to the pad, entered their spacecraft, began checking it out, and those operations also running a little bit ahead of schedule. We went on to our terminal countdown sequencer at the 3-minute 6-second mark as scheduled. Everything seemed to be proceeding fine. At the T-minus 30-second mark, we got an automatic cutoff. It was determined that this cutoff came because pressurization of the liquid oxygen tank aboard the 3rd stage was not initiated automatically as it should have been. When it was done manually, the terminal sequencer did not sense that this had been done and therefore gave the automatic cutoff. We're working the problem right now, continuing to hold at the T-minus 8-minute mark. T-minus 8 minutes and holding. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, continuing to hold at the T-minus 8-minute mark. The hold continues to be planned for approximately 5 to 7 more minutes. However, the launch window, it should be pointed out tonight, extends to 1:31 a.m. Now, if for any reason we could not make it in that launch window, we could recycle under our present configuration and resume our count, aiming for a 9:53 p.m. Eastern Standard Time launch tonight. The window for tonight is the same as it was for last night and this morning, 9:53 p.m. to 1:31 a.m. However, the launch team appears to be optimistic with the solution they've found to the problem. They're just waiting for verification and confirmation from the testing going on at the Marshall Space Flight Center in Huntsville, Alabama. The time now is 7 minutes after midnight. We're continuing to hold at T-minus 8 minutes. T-minus 8 minutes and holding. This is Kennedy Launch Control. Apollo Saturn Launch Control continuing to hold at the 8-minute mark in the countdown. Still awaiting word from the Marshall Space Flight Center in Huntsville, Alabama, and the result of the test being run at this time up there. Meanwhile, here in the firing room, all elements of the launch team are assessing their position. They are assessing the effect of the hold and this amount of hold time on each of their systems. Everyone at this time busily at work here in the firing room, also at the Mission Control Center in Houston, busy there with their flight updates. Now continuing to hold at the T-minus 8-minute mark, this is Kennedy Launch Control. Apollo Saturn Launch Control, we're at 15 minutes past the hour, continuing to hold at the T-minus 8-minute mark. Test supervisor just indicated that we plan to pick up the clock at the T-minus 8-minute mark in 10 minutes, planning to pick up the clock at 25 minutes past the hour. The tests being run at, or have been run now at the Marshall Space Flight Center, and indicate that our system is good the way it has been reconfigured. All elements now during this 10 minutes will be preparing their various systems to pick up the clock at the T-minus 8-minute mark. Meanwhile, out at the Manned Spacecraft Center, the flight controllers there are also planning to pick up the clock. We just received a go from the Superintendent of Range Operations indicating that the range has been cleared around the new flight azimuth. Manned Spacecraft Center Houston flight indicates that they are go to pick up the clock at 25 minutes past the hour. Now T-minus 8 minutes and holding. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're continuing our hold at the T-minus 8-minute mark. We have approximately 5 more minutes remaining in that hold. It's been determined that the workaround is a correct and satisfactory one. A breadboard or a sample system at the Marshall Space Flight Center was used to run through the entire sequence as it's now configured, and that operated satisfactorily. What happened was during the terminal sequencer, the liquid oxygen tank was not pressurized automatically. When this was done manually, the indication did not get to the sensors in time so that we had an automatic cutoff. The liquid oxygen tanks aboard the third stage, it's been determined, will be pressurized manually early in the terminal sequence, and jumpers have been installed so that we can then feed the information to the sequencer so that it will not have an indication that the LOX tanks have not been pressurized. This A breadboard situation of this has been constructed at the Marshall Space Flight Center in Huntsville, and this has operated satisfactorily. So it's been determined to go ahead with our countdown on this basis. We'll be planning to pick up the count at the T-minus 8 minute mark some 4 minutes from now. Now T-minus 8 minutes and holding. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're now resuming the count. T-minus 7 minutes, 54 seconds, and counting. At this time in the spacecraft, updates being given to the spacecraft commander, Eugene Cernan. The swing arm still at the 12-degree position. That's the park position, standing by at the spacecraft. That will be brought back to the full retract position at approximately T-minus 5 minutes in the countdown. The flight director just ran through his team, a status report from his team at the Mission Control Center. That team all reported they are in a go condition. Now T-minus 7 minutes, 20 seconds, and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 5 minutes, 40 seconds, and counting. At this time, the various elements of the launch team have been reporting into Bill Schick, the test supervisor, indicating that we are go to continue. Mission Director Chet Lee just verifies that we are go for launch. Safety indicates that we have a go. First stage test conductor, this is the man who has charge of those 5 first stage engines, which will give us the liftoff, has indicated a go for launch. Launch operations manager Paul Donnelly also giving us a go for launch. And finally the launch director Walter Caprian says we are go for launch. We've passed the 5 minute mark now, and swing arm number 9. This is the access arm to the spacecraft, is coming back to the full retract position. It moves back alongside the mobile launch tower, and it will remain there now through the final portion of the countdown and the launch. At the T-minus 60-second mark, 20 nozzles will start flame deflector deluge of 13,000 gallons per minute of water pouring down on that flame deflector. So a great deal of what is seen at launch time, which looks like smoke, is actually steam as this water is burned off. This water to cool the pad area and to cool the equipment alongside of the launch tower, as the water also pours across the swing arms and the launch tower. We're approaching the 4 minute mark in the countdown now. T-minus 4 minutes, 5 seconds, and continuing to count. At the 4 minute mark, we'll stand by for a final go from Norm Carlson, the launch vehicle test conductor. He's given a go. The launch operations manager now switching over to the Astrocom circuit. This is the circuit that the astronauts, the launch operations manager, and the spacecraft communicator will remain on. They have this private circuit to keep extraneous talk off of their circuit. They are checking in. They are checking in now on the Astrocom circuit, indicating that they are go. Spacecraft has indicated they are ready. Instrument unit ready light has come on. S1C, that's the first stage. Preparations are now complete as we approach the 3 minute mark. There's quiet in the firing room now as the engineers and technicians are monitoring their consoles. They're monitoring the various rates, pressures, temperatures. They can override the terminal sequencer if they cite a problem that it has not picked up. We are on that terminal sequencer now. We've passed the 3 minute mark, T-minus 2 minutes, 47 seconds, and counting as we are on the terminal sequencer. At the T-minus 50-second mark, we'll be looking for that critical power transfer. This is where we transfer from the external power source, which has been feeding the 3 stages of the launch vehicle, to internal power. That's to the flight batteries aboard the space vehicle. It's expected that given proper weather conditions, people will be observing this flight from as much as 500 miles away. This includes a large portion of the southeastern United States, the northern tip of Cuba, and the Bahama Islands. Now approaching the 2-minute mark. Mark, T-minus 2 minutes and counting, and the countdown continues to move along smoothly. Now in the terminal countdown portion. The automatic sequencer has stopped the replenishing of the liquid oxygen and the liquid hydrogen. We're standing by now to begin pressurization of the fuel tanks. The second stage fuel tank pressurized, third stage fuel tank pressurized. The countdown continuing to move along smoothly. T-minus 90 seconds. T-minus 90 seconds. Countdown continuing smoothly. S4B propellants pressurized. The indication now using the workaround showing the S4B propellants have been pressurized. Now looking at the liquid hydrogen tanks as they become pressurized. LH2 aboard the second stage pressurized. All propellants now aboard the second stage pressurized as we approach the 1-minute mark in the countdown. Mark, T-minus 1 minute and counting, now in the final minute of the countdown. At T-minus 45 seconds, Gene Cernan will make the final guidance alignment. This is the Mark, T-minus 45, and Gene Cernan made that final guidance alignment. That's the last action taken by the crew aboard the space vehicle. Now approaching the half-minute mark. T-minus 33, T-minus 30 seconds, and continuing on now. Continuing on at the T-minus 26-second mark, T-minus 25. We'll get a final guidance release at the T-minus 17-second mark. T-minus 17, final guidance release. We'll expect engine ignition at 8.9 seconds. 10, 9, 8, 7, ignition sequence started. All engines are started. We have ignition. 2, 1, 0. We have a liftoff. We have a liftoff, and it's lighting up the area. It's just like daylight here at Kennedy Space Center as the Saturn V is moving off the pad. It has now cleared the tower.
Tower, yaw's complete. We're in the roll, Bob.
Roger, Gino, looking great. Thrust good on all 5 engines.
Okay, babe, it's looking good here. Roll is complete. We are pitching.
This is Mission Control, Gene Cernan reporting the launch vehicle maneuvering to the proper attitude. Everything looking good at this point.
17 is go.
Roger, 17, your go.
First stage looks good. Altitude 1.1 miles. Booster says we look good. We're now at 2.5 miles.
Mark, mode 1 Bravo.
Roger, 1 Bravo. We're go at 1 minute.
Roger, Gene, you're looking great. Right on the line.
Everybody says looking great. Right on the line. We're now 1 mile downrange. Launch vehicle 4.2 miles high. Coming up on maximum dynamic pressure at this point. 4 miles downrange, 8 miles high, and the velocity approaching 3,000 feet per second.
Looking great. Stand by for mode 1 Charlie, 17. Mark, mode 1 Charlie.
And the flight dynamics officer says we look good on all sources, right on the trajectory.
Roger, 17, your go.
Flight Director Gene Kranz taking a status for staging. We say we look good for staging.
Roger, we'll go here. Inboard cutoff.
Roger, inboard.
Inboard engine shutting down on time as planned. Crew will experience maximum G-forces of about 4 Gs at shutdown. Coming up on first stage shutdown. And we've had shutdown on time on the first stage.
5.
Roger, they're looking here, looking good.
Sure felt like it. I think we saw them all from here.
Roger, Jack, and the thrust is going, all 5 of them. They're running good.
Okay, 3 minutes in, we're go.
Roger, 17.
Okay, we do have skirt set.
Roger, we confirm skirt set.
There goes the tower. Ah, there she goes.
Roger the tower, you're mode 2.
Roger, mode 2.
The steering has converged and CMC is go. You're going right down the pike, 17.
Okay, Bob, I do confirm guidance.
That's the automatic guidance system, the inertial guidance system performing properly.
Breakers, and we've seen it all. Ignition, staging, and tower.
Roger, got you.
Apollo 17 now 65 miles high.
Okay, 4 minutes, and we're go here, Bob.
Roger, Gene, we're going around the room. Look, go here. You're looking real good, Gene. Right down the line.
Okay, 4:30, and we're still go on board.
Roger, 17, you're go.
Let me tell you, this night launch is something to behold.
Coming up on 5 minutes, everything still looks very good in the launch of Apollo 17. The launch vehicle spacecraft now 80 miles high, 230 miles downrange.
Five minutes, Gino, and you're go down here. You're looking great.
Okay, Robert, we're go here at 5.
Houston, your times are nominal. Level sense arm at 8 plus 36. S2 shutdown at 9 plus 20. Nominal times.
8 plus 36 and 9 plus 20. Roger here.
Capcom Robert Overmeyer advising Gene Cernan and the crew aboard Apollo 17. The second stage shut down at about 9 minutes 20 seconds elapsed time. That shut down about 3.5 minutes from now.
Stand by for S4B to COI capability. Mark, S4B to COI capability.
Roger, S4B to COI, we're go at 6.
Roger, Dino.
Apollo 17 still right on the nominal trajectory at an altitude now of about 92 nautical miles.
We got 4 good motors and we're go at 620.
Roger, and 17, we copied the gimbals and we watched them. They're looking good. Stand by for S4B to orbit capability. Mark, S4B to orbit capability. And we'd like Omni Delta, Jack.
Roger, you've got it.
Roger.
Now 7 minutes in, and we have sufficient velocity to make orbit with the Saturn third stage should we have an unexpected early shutdown of the second stage.
Good on board.
Roger.
We're now less than 2 minutes from second stage shutdown and ignition of the Saturn third stage. And the center engine will be shutting down as scheduled in about 10 seconds.
We have inboard cutoff.
Roger, Gene, inboard on time.
And that inboard shutdown looked to be on time. Apollo 17 now 625 miles downrange, 93 miles in altitude.
8 minutes and we are go.
Roger, 17, you're looking great.
The spacecraft guidance system is agreeing very closely with the Saturn guidance. It looks good.
For staging.
Thank you, Bob. We are go for staging up here.
Staging now less than 1 minute.
You have level sense arm this time, Gene.
Roger, Bob. Level sense arm.
Apollo 17 traveling at 21,000 feet per second. It's achieved about 83% of the velocity required for a minimum orbit.
Nine minutes, Bob, and 17 is go.
Roger, 17, you're go here.
And about 10 seconds to staging.
Stand by for mode 4 capability.
S2 cutoff.
Mark, mode 4 capability, and we copy cutoff.
Roger, mode 4. And we do have S4B ignition.
Roger, we see it, and the thrust is looking good on it.
We saw that one too, Bob.
Roger.
We're up to 23,000 feet per second. We'll be shooting for something over 25,000.
17, the steering has converged, and the CMC is go. You're looking great.
Roger, the CMC is go, 10 minutes, and 17 is go on board.
17, Houston, you are go for orbit. Go for orbit.
Those are kind words, Robert. We're go for orbit here.
Good show, Gene.
Coming up on 10 minutes, 30 seconds after liftoff. And the spacecraft launch vehicle now 11,000, or 1,100 miles rather, downrange, and altitude 93.4 miles.
Roger, 17, you're looking great.
And we're about 1 minute from shutdown, about 1 minute from orbit insertion.
Minutes and we are go.
Roger, Gene, and cutoff will be at 11 plus 47. 11 plus 47.
11 plus 47, Roger. Okay, 11:30, and we're go here and stand by.
Roger, Gene. Cutoff time is still holding good, 11 plus 47.
Okay, cut off at 4-2.
Understand, cutoff at 4-2. Roger, we copy.
And that looked like a near nominal shutdown. At shutdown, we show 25,600 feet per second. That also looks very close.
89.5.
Roger, Gene, we're copying the disk key.
Okay, Jeff, come on.
Gene Cernan reporting the onboard indication of an orbit of 93.5 by 89.5. We'll be getting tracking and confirming that here on the ground.
And Houston, looks like the tank pressures are venting.
Roger, Gene, the range safety is safe, and you are in a go orbit nominal.
Roger, go orbit nominal, thank you.
And 17, I'll be unable to update that AOS time, but 52:20 is looking good.
Roger.
This is Apollo Control coming up on 14 minutes after liftoff. That liftoff coming about 2 hours, 40 minutes late. And we'll be assessing the effects of that late liftoff on subsequent events in the mission timeline, passing those along. One of the effects will be a change in the acquisition of signal, loss of signal time as we move along on the ground track.
C off.
Stand by on that, Jack.
I've been carrying very low amps on the bat bus, and I did not see a drop. I'm carrying about 2 amps now. Volts are 30.5.
Jack, go ahead and take the BC motor switch off.
Okay, it's off, and I confirm that one.
And we think it's the EDS power switch and the fuel cell latch switch that are drawing the current that you're seeing there.
Okay, that could well be.
Okay, Jack, we're going to lose you in about 1 minute off of Vanguard here and see you at 52:20.
Roger, we're pressing. Thanks, Bob. Okay, Bob, everything is looking go on board. Everything's stable. We can see the apps firing, and our attitudes look good.
Jano, everything's in good shape down here. The booster's in good shape. You're looking good, and our AOS time is 52:20 as I gave you.
We got that, babe. We'll see you coming around.
Good show, babe. A little late, but a good show.
Outstanding ride.
Houston, we're hanging with you here. It looks like you're hanging in Vanguard a little longer than we expected.
This is Apollo Control at 16 minutes 45 seconds after liftoff. We've confirmed Apollo 17 is in a near nominal orbit. The crew reported an orbit of about 93.5 by 89.5 based on their onboard calculations. And computations on the ground show that we're very close to the nominal 90-mile nautical mile orbit. As a result of the late liftoff, the translunar injection will be a little bit earlier than the flight plan ground elapsed time. We don't have an update on this time yet. We expect that it will be on the order of 8 to 10 minutes early. We will update that time as we get a later update. We would expect that the time of arrival at the moon will be approximately the same as the flight plan time. in terms of Greenwich Mean Time. The ground elapsed time will be somewhat earlier, and we expect that there will be a clock update, a so-called clock update, at some point where we make the clocks in mission control and aboard the spacecraft agree with the ground elapsed time that they would be showing in the flight plan. The net effect will be that we'll arrive at the moon in a shorter ground elapsed time, in effect about 2 hours, 40 minutes earlier than the flight plan would show, but at the same Greenwich Mean Time, or local time here on Earth, that we would have had we lifted off on time. We're in effect making up the time by speeding up the arrival at the moon. The spacecraft at translunar injection will be going somewhat faster than a nominal liftoff translunar injection. Consequently, it will arrive at the moon going slightly faster, and also somewhat earlier, about 2 hours, 40 minutes earlier in terms of ground elapsed time. This will also mean that the lunar orbit insertion will require a bit more energy to slow the spacecraft down and get it into lunar orbit. These details, of course, will all be worked out in the time that we have before lunar orbit insertion. And when we get an updated translunar injection time, we'll pass that along. This is Apollo control at 24 minutes. Apollo 17 now in an orbit about 90 miles by 93 miles. And everything appears to be nominal aboard the spacecraft and aboard the launch vehicle, Saturn third stage. One additional impact of our late liftoff will be the loss of television coverage for the transposition and docking maneuver. The television coverage will not be possible because the ground track has shifted. We don't have the site coverage that had been expected for television. The translunar injection burn, reigniting the Saturn third stage to put the spacecraft on its trajectory to the moon, is now scheduled to occur at a ground elapsed time of 3 hours, 12 minutes, 35 seconds, or roughly 9 minutes earlier than the flight plan time. This again the effect of the late liftoff. And we'll be reacquiring Apollo 17 through the Carnarvon tracking station at a ground elapsed time of about 52 minutes 20 seconds, roughly 27 minutes from now. This is Apollo Control, now 32 minutes after the liftoff of Apollo 17. We have loss of signal with the spacecraft. We'll be reacquiring through the Carnarvon tracking station in about 20 minutes. And from the President of the United States, we have the following message to the crew of Apollo 17. The message reads, "As you set forth on the final Apollo expedition to the moon, I want to have my personal best wishes for a successful mission and safe return. I am sure your voyage of scientific exploration will be the crowning achievement in a program which has expanded man's horizons, brought great credit to your country, and lifted the spirits of people all over the world. Godspeed to you all." Signed, Richard Nixon. The flight dynamics officer, continuing to process tracking data following orbital insertion, reports that there is a small amount of out-of-plane error showing up in the orbit. This, it is believed, is due to a small error in the instrument unit of the Saturn third stage. However, the orbit is very close to nominal, about 90 nautical miles by 93 nautical miles. And we look very good, both with respect to the spacecraft and with respect to the Saturn third stage, which must perform that burn, putting Apollo 17 on its trajectory toward the moon. At 34 minutes, this is Apollo Control, Houston. This is Apollo Control. The post-launch press conference at Cape Kennedy is scheduled to begin at 12:33 Central Standard Time, 1:33 a.m. Eastern Standard Time. Again, that time, 12:33 Central Standard Time, 1:33 Eastern Standard for the post-launch press conference at Cape Kennedy. Control at 51 minutes into the flight of Apollo 17, and we're standing by to reacquire the spacecraft through the Carnarvon Australian tracking station. One of the things that the booster engineer will be looking for when we reacquire and get good lock on the data will be the Saturn third stage instrument unit. Looking at one brief bit of data before we lost signal, it appeared that one of the 4 batteries in the instrument unit had a very high current drain on it. We will be looking closely at that to see if it was simply a telemetry problem, or if in fact that battery does have some problem. And we should be about 15 seconds now from reacquiring.
Some here, you might want to know this, Jack. Your sunset and sunrise times in the launch checklist are all off by approximately 8 minutes and 30 seconds. That every sunset and sunrise will occur about 8 minutes and 30 seconds sooner than in the launch checklist. That's an approximate number.
Okay, we got you.
Okay, and on page 2-17 of the launch checklist, you're going to want to delete all reference to honeysuckle, AOS, and LOS, and delete all reference to canaries, AOS, and LOS.
Okay.
And we want to add an ascension, pass AOS at ascension 1 plus 54 plus 00, and ascension LOS will be 020016.
Okay, Bob, you're going to have to repeat that.
Okay, stand by. Let me give you a page. On 2-17, let's go Hawaii AOS first of all. On a Hawaii AOS on page 2-17, AOS is 01 plus 17 plus 24. Hawaii LOS 01 plus 22 plus 49er.
Gotcha. Now, what about the ascension?
Okay, here, give you the ascension again now. The AOS 1 plus 54 plus 00. Ascension LOS will be 020016. Over.
Okay, I got those. Hawaii is 1 plus 17 plus 24. And LOS is 1 plus 22 plus 49, and ascension is AOS 1 plus 5400, and LOS 2 plus 0016.
Roger, Jack. Good copy, and booster's looking good down here, and looking good.
Okay, and I'll do a better job of itemizing those switches. We were pressing pretty hard, and I'll be able to go back and get most of them, I think, and we'll keep an eye on it on the master alarms.
Roger, Jack. We understand, and I think we copied most of what you said there, and we're working on it.
Okay, Bob, other than that master alarm, all is well in America, and understand the booster is looking good to you?
That's affirmative.
And Bob, let me add that we did get spurious master alarms without switch movement, but many came with switch movements. We've had about 7.
Okay, understand.
That was only after insertion.
7 times that your heart doesn't need, huh?
Oh, we were paying attention to a sunset that was the biggest, or sunrise or something that we saw. It was the biggest rainbow I'd ever seen.
Beautiful. We can't wait to hear what you had to say about that. The ignition on the S2. It sounded pretty spectacular.
Well, just let it be said that that was quite a booster ride. We got a chance a little later. Maybe we'll
Roger.
tell you about.
We're about ready to lose comm here. You're looking great, guys, and we'll pick you up in Hawaii here shortly.
Okay, we're looking at the deserts of Australia right now, and again, everything's good on board.
Roger. Pick you up at 1:17:24.
Gotcha.
This is Apollo Control. We're coming up now on 1 hour after liftoff for Apollo 17. And as you heard, Capcom Robert Overmeyer reporting to the crew that everything looks good, including the Saturn third stage. Apparently the indication we had of a possible battery problem in the instrument unit, nothing more than a bad bit of telemetry there. When the booster engineer got a good hard look at the telemetry on this pass, reported everything looked good. We're ready at this point to begin the post-launch press conference at Cape Kennedy. We'll switch to Cape Kennedy now and stand by for that press conference. This is Apollo Control, 1 hour 25 minutes after liftoff. During the post-launch press conference at Cape Kennedy, we had a short acquisition with the crew through the Hawaiian tracking station. During that period of conversation and during that period of monitoring the systems on the spacecraft and the launch vehicle, we found that the situation was essentially unchanged. That is, both vehicles looking good, the spacecraft and the launch vehicle. And we're progressing toward a normal translunar injection 1 hour, 46 minutes, 50 seconds from now. The crew has discussed one unexplained series of events. It appears that when certain switches are cycled or moved, on panel 2, which is the main panel in front of them, the center panel of the spacecraft, they're getting a master caution and warning signal. A light comes on, a tone comes on. This is to attract the crew's attention that something may be wrong, and the normal procedure is then to look at another matrix of lights which would zero them in on the problem. The light, or the system or subsystem or particular area being monitored which had the problem would light an individual light. However, when they go to this other matrix of lights, they find that none of them are lighted. This is leading the crew and flight controllers here in Mission Control to believe that they're getting a spurious signal to the master caution and warning when in fact nothing is wrong. We don't have any further explanation for the problem at this point. We will continue to look at the data, and particularly during the translunar coast, we think we'll get a good long time to look at things in detail and try to find out precisely what is happening. At this point, however, the problem presents no concern, and one of the more likely explanations, or possible explanations that's been advanced, is perhaps some contamination in some switches. We did accumulate some taped conversation during the press conference with the crew. We'll replay that for you now, and then stand by for acquisition of signal over the United States.
Hello, Earthlings. We're back with you.
Roger, Jack. Lead you loud and clear. How is?
You're loud and clear, and no change systems-wise that I've seen.
Roger, Jack. Any more master alarms?
We had one when Ron's, looked like his neck ring hit panel 2.
Okay, sounds like we had something loose in panel 2, huh?
Yeah, I don't know. It may be annoying, but so far it doesn't seem to be a problem.
Roger. Just for your information, everything is looking outstanding and no problems. We're taking a good look at the data here at Hawaii, and we'll make a go, no-go decision about 60 seconds after acquisition at Goldstone, but there's nothing right now to lead us to believe a zero opportunity will be required.
Okay, Bob, understand that. We are prepared, however. Spacecraft, other than those master alarms, is looking very good. We got the docking probe extended. The SCS reference attitude check is complete.
Roger.
Okay, Bob, I just remembered another switch that I think gave us a master alarm was H2O quantity indicator.
Oh, Roger, copy that, Jack. H2O quantity indicator. Roger, 17, we're going to lose you in about 30 seconds, but when you get over the stateside here, we're going to take the dump on the data, and we'll read it out real carefully, so when you get in PLC, we ought to be able to see where that master alarm glitch is coming into.
Okay, Bob, and yell at me if you want anything done on the comm with this change in AOS, LOS stuff.
Negative on that right now. We'll see you at 128.59 through Goldstone.
Okay, 128.59, Bob. We'll be there.
Roger, Jay. 17 Houston, we're back with you.
Okay, Bob. We're still same as before, and ready when you are for TLI.
Roger.
I can see the lights of Southern California, Bob.
Roger, Jack.
We're going to be going a little bit south of that area.
Right, your ground task looks like it's picking you right up over the mid part of Baja, California.
Yes, sir. I'll believe that. I'll bet you I can see Ensenada right now.
Roger.
Bob, I expect you'll probably be able to see the lights of Silver City, too. Well, I'm sure going to be looking for them, I'll tell you.
Jack, just for your information, you'll probably, when you come up a little further in this orbit here, get over Mexico, you should be able to see all that bad weather that was giving us so much worry, and had Tyndall and New Orleans and everything all messed up this morning when I went through there. We had a pretty bad line of weather along there.
I was assuming it wasn't too bad. I think you made it, didn't you?
Oh yeah, I made it, but I had to, had to work at it. But it's I was worried about it getting down to towards Mila there after, you know, if we had to scrub and go tomorrow night. And boy, I'm sure glad we got you off tonight.
Guess who else is?
And I wouldn't believe that. Parker can't make it back. He's got to come back on the Gulfstream, so you might have to have Young on for a while after we do a TLI.
Hey, you just wouldn't believe, Bob, the lights you can see in the west right now. It must be absolutely clear.
Roger, Jack. Sounds spectacular. Jack, people in the room here want to know if you've been down your checklist yet.
Oh, we got that out of the way in about 5 minutes. Have we missed something?
Oh, there's a different checklist here we were talking about.
If you're talking about the flight plan, yes.
Roger.
What a waste. If I'm not mistaken, we must be just south of Arizona now. Is that right? Right, Bob?
That looks real good. Yeah, you're over Mexico there. It looks like you're, maybe 100 miles south of the border there.
Okay, I was pretty sure I was looking up in the Phoenix-Tucson complex there.
I understand.
Beautiful.
A little better than when we go back north, huh?
Well, the west is always that way. I wish it was daylight so we could see Sonora in that country. That's spectacular, I'll bet you.
Right.
Bob, you're coming through with a large squeal right now in the background.
Understand.
Okay, I think we've got the Gulf Coast showing up now by the band of lights, Bob.
Roger.
Okay, Bob, assume the booster's still looking good and we'll be go for a nominal TLI.
That's
Okay, and you're still coming up with a loud squeal.
Roger. 1790.
Would you believe we're just south of Houston now, Bob?
You receiving Houston now?
Sorry, Bob, you came up unreadable with the squeal that time.
Am I still squealing? This is Houston.
That's the firm. You're very loud, almost unreadable with the squeal. Bob, why don't you give us a short count?
Gino, don't change anything. We think it's a ground site situation here, and just stand by.
I believe it's in the VHF, Bob. Okay, Bob, I'm not sure exactly where we are, but I'm looking out to an awful lot of lights on the horizon out there at 12 o'clock, and an awful lot of lightning in the clouds out there.
Roger, we show you just about over the middle of the Gulf. Looking ahead, you're probably seeing the very southern tip of Florida there.
It looks like almost the entire Florida peninsula has got lights outlining it somewhere.
Roger. How's my comm sound to you now, Gene?
Okay, give us a quick short count.
Roger, short count follows. 5, 4, 3, 2, 1. 1, 2, 3, 4, 5. Short count out.
Bob, you're all right now?
Okay.
And can you give us a feel for what the final weather was at the Cape at launch?
Yeah, let me get that for you. The reason why we had that problem on the comm is we just handed over from Texas to Mila, and we're going through Mila now, and it's great, so we got a little problem with our Texas site.
Okay.
The television coverage had you all the way through staging very well on the S2 ignition and that, and you went right behind a cloud for a while, but they were tracking you pretty well.
Okay.
They also cut in for about half a minute or so and showed a view of the crowd in just the available light from the booster, and it stood out pretty well.
Okay, Bob, we're going right over Florida now, looking down at Miami, a beautiful view of the Keys all lit up, and I just saw a shooting star right over Miami.
Roger.
That's a very, very fine view of Miami. Hard to believe.
I'll bet they sat there and watched you go.
Looks like we're right over the Bahamas now, Bob.
Roger, I'll buy that.
Well, I'm not easily impressed, Bob, but I'm certainly impressed by this one.
Roger. What's the CMP doing? We haven't heard much from him. Is he at the other window?
He's crawling around looking for things down in the LAV.
Okay. They won't let you have a window tonight, huh, Ron?
Catch one here pretty quick.
Just a reminder, if you haven't already done it, there's no need to unstow the TV because due to this late launch, there's just no site available.
Okay, Bob, we're not going to install it. Bob, I guess there's no site available for some time, is that correct?
That's affirmative, and if I can pull one of you guys away from a window, I've got a TLI plus 90 pad.
Oh, I'd love to copy that. Just a minute. Houston, Apollo 17, how do you read?
17 Houston, go ahead.
Okay, lost you there for a minute. We had good signal strength all through that, so I figured it was your problem.
Roger, we were just waiting to hear from you. You ready for the pad?
We were calling you and you missed us, so you might think about that. Ready for the pad.
Okay, it's a TLI plus 90. SPS GNN. 669er53 minus 059er plus 188. Ignition time 004400148 minus 03518 minus 00001 plus 33782. Roll is 180073 Now 94 is HA is not applicable. HP is plus 00201 339er64 450 33808. Section star is number 11. That's 113424 323. Stand by. 17 Houston, are you still reading me?
If you read, we're reading you, got you all the way through the trunnion on section star.
Okay, we'll have to wait and pick you up at Ascension. We just had a keyhole pass at Bermuda and a little bit of pass at Vanguard.
Okay, I'll wait for you to finish that and on the readback, okay?
That's affirmative. Stand by, we've got Vanguard. I can continue on with, after trunnion, the boresight star is not applicable, Jack. Noun 61 plus 1329er minus 03200 109er92 349er04 GET of 05G 0243809er. Want to read back that much of the pad, Jack?
Okay, Bob, it's TLI plus 90 pad, SPS GNN, 66953 minus 059er plus 188 004 400148 minus 03518 minus 4 zeros 1 plus 33782 180 073 003. HA is NA plus 00201 33964 454 33808 11 3424 323. Boresight is NA plus 1329er minus 03200 10992 34904 024 3809er. Over.
Roger, Jack. Good readback, except burn time is 450 and not 454. And we'll be losing here in about a minute, so I'll wait on the rest of that pad. Just a reminder for Ron, we'll be standing by at Ascension for the next gyro torquing, and we might have a drift update on the IMU there.
Okay, he copied that, and we'll wait for the rest of the pad.
Okay.
Burn time was 450. I think that's where you started to cut out.
Roger. 17, this is Houston through Arra. How do you read? Over. Houston through Arra. How do you read? Over.
Houston to Arra, how do you read? Houston, how do you read to Orion?
This is Apollo Control at 1 hour 51 minutes. We're getting good telemetry data from Apollo 17 through one of the Apollo range instrumented aircraft out over the Atlantic Ocean. Apollo 17 moving across the Atlantic now towards Africa. And on the next revolution, at about this point, the spacecraft will be on its way to the moon doing the translunar injection maneuver. Ignition for that burn is scheduled to occur 1 hour 21 minutes from now. During launch, the flight surgeon monitoring heart rates on the 3 crewmen recorded peak heart rates of 130 for the commander, Eugene Cernan, also 130 for command module pilot Ron Evans, and 115 for lunar module pilot Jack Schmitt. We should be reacquiring the command service modules and reestablishing voice communications with the astronauts in about 2 minutes from now through ascension. This is Apollo Control. We should be acquiring the spacecraft through ascension in about 5 seconds and reestablishing voice communications with the crew.
Houston.
Go ahead.
Hi, Roger, you're back with us. I'll finish up that TLI plus 90 pad so we can talk a little here if you want.
Go ahead.
Okay, set stars are Sirius and Rigel. Our line is 318, 148, 358. There'll be no LH. Okay, down at the bottom of the pad we got the P37 for liftoff plus 9er. GET is 009000. Delta VT 48907. Longitude minus 175. GET of 400K 03349er, over.
Okay, Bob, Sirius and Rigel, 318, 148, 358. No LH. 00900, 4897, minus 175, 03349er, over.
Okay, Jack, good readback.
Okay, Bob, we had, as usual, up here, a spectacular sunrise, and Gene wants to talk to you. I got some numbers on route speed 52 for you, Bob.
Okay, standing by the copy, go ahead.
Okay, now it's 71, we're stars 22 and 24. 905 are all balls. Now 93s are all minus. They're 00037, 00007, and 00021. That's minus 37, minus 07, and minus 21, and they were torqued at 151.40.
Okay, we copy.
Bob, we're over what might be intermediate to low stratus that have a very strong crenulation pattern, pulling out some geological terms here. I don't think I've ever seen anything like it flying.
Roger.
Looks like about a north-south lineation with a very strong crinkling, roughly east-west.
Roger, copy that. That's interesting. You know, you're just directly over that South Atlantic area. Your path just kind of kept you going right between the Africa and South America, right dead center all the way. And 17, just for your information, we've searched all the data we can, and we cannot find anything wrong with the spacecraft or the booster at all. Everything's looking real fine, and the only problem in the air is that those master alarms which you have reported, we're not able to tie in anything common yet to any of those things either.
Okay, Bob, we have not had any for quite some time, I think, since the last time we talked to you about them.
Roger, understand. We'll probably get a good workout on that after TLI and try and track it down a little more.
Okay, but also we have not really been doing much switching since the insertion checklist was complete either.
Roger, understand. Got you glued to the windows, I guess, huh?
They are interesting, I'll say that. Well, I certainly am, Bob, and again, there's a fairly continuous intermediate cloud deck, I think, and it has patterns comparable to what I've seen on pictures of ice flows.
Roger, understand.
Or pack ice, I should say. Pictures of pack ice from the Antarctic.
Houston, we've got two questions concerning the master alarms. One, do you get the master alarm on the LEB also? And two, do you get the tone with the master alarm?
We did get the tones. The master alarms were on both panel 1 and panel 3. I can't tell you about the LEB right now. Maybe Ron can. No, I didn't pay that much attention.
Okay.
Hey, Bob, there was something interesting, and I want to get around and tell you. The mission timer down in the LEB, when Ron went down there to get things squared away, was about 15 seconds or so behind all the other clocks.
Roger, we copy that.
Okay, and we reset it, resynced it, and it's been running okay. I don't know whether that's include anything or not, but apparently it happened either during launch or somewhere before we got down there, right after insertion.
Okay, we're going to lose you here in about 9 seconds. You're a go and looking great, and we'll work on it. And if you get another MEB, will you check the LEB for us?
Yes, sir. Sure will do, Bob. We'll see you. What's our next AOS?
Stand by. Carnarvon at 225.
Thank you.
This is Apollo Control, Apollo 17 now over the horizon from the ascension site. We'll be reacquiring in about 25 minutes through Carnarvon. And as you heard Capcom Robert Overmeyer advising the crew, we've been getting a good look at all the data, and spacecraft, launch vehicles look fine, no discernible problems. Gene Cernan did mention one anomaly, and that was the mission timer. One of the numerous clocks aboard the spacecraft, which was running about 15 minutes slow. And Cernan said it appeared that it happened either during the launch phase or shortly before they got down to take a look at it in the lower equipment bay. No explanation for that one at this point. And we show now 1 minute, or 1 hour rather, 11 minutes until ignition for the translunar injection maneuver, the burn with the Saturn third stage that will place Apollo 17 on its trajectory toward the moon. Ignition time still holding at about 3 hours, 12 minutes, 35 seconds ground elapsed time, and that burn will be about 5 minutes, 45 seconds in duration. We don't have the final calculated time from the flight dynamics officer, which will undoubtedly vary somewhat from the pre-mission flight plan time. At 2 hours, 2 minutes, this is Apollo Control, Houston. This is Apollo Control at 2 hours, 25 minutes. Apollo 17 now approaching the west coast of Australia. And we'll be reacquiring the spacecraft in about 35 seconds. During this pass over Carnarvon, we expect to pass up the first set of numbers to the crew that they'll use in the translunar injection burn to put them on their trajectory towards the moon. That maneuver is scheduled to begin at 47 minutes from now. And we have acquisition of signal a little bit early.
17 Houston, how you doing?
Well, we're pretty good. You're wavering here a little bit on signal strength.
Okay, we've got a TLI pad anytime you're ready to copy it, Jack.
Goodness, okay, let me get rid of something here, Ron. I'm putting that right underneath you.
And guys, we'd like poo and accept, please. You're getting a CSM state vector if you'll give us poo and accept.
Got poo and accept. Okay, let me have my favorite pad.
Okay, here's a TLI pad. Time base 6 at 30257. 180 312 000 551. Delta VC is 10359er6 35582 000 345 040. Extraction will be at 300-165-320. 3120-3060-5710. Yaw is 0. Ejection time 4 plus 3 9er plus 0 0. Over.
Houston, there's your TLI pad, 30257 180 312 000 551 103596 35582 000 345 040 300 165 320 3120 3060 5710 000. Ejection time 4 plus 3 9er plus 00.
Good readback, Jack, and we'd like Omni Charlie. And it's your computer, and you've got your state vector.
Okay, you got Omni Charlie. And Bob, we had almost a completely weather-free pass over Africa and Madagascar. And the scenery, both aesthetically and geologically, was something like I've never seen before, for sure.
Roger.
We got odds and ends on the tape and quite a bit on the film.
Roger, good show. You're saying that you didn't have any weather over that southern Africa there?
Not very much. Barely broken clouds in some places. Most of the countryside was clear.
Roger.
There were patterns like I hadn't even seen in textbooks. Maybe I haven't been looking enough, but some of the desert and grassland patterns were had the appearance of ice crystals almost, except on a mega scale. If you ever looked at ice crystals in sand.
Roger.
Or better yet, ice crystals on your car window when you get out early in the morning up in the northern areas.
Roger. And just be advised, we'll be standing by for the go, no-go for Pyro Arm when we get to Hawaii, and we'll be giving you a go for TLI about that time.
Okay, and we'll be ready.
And Ron, on the launch checklist on 2-25 on the manual and nominal S4B TLI-1, add 34 degrees on the nominal pad for all the pitch angles, and on the manual pad add 34.5 degrees to all the pitch angles, and you'll have it right.
Okay, Bob, give us a to get set. That's okay, we'll just add 34 to the nominal and 34.5 to all the manual ones.
And you'll want to do that on your cue card also, Ron.
Okay, that's affirmed.
And we're about ready to LOS. We'll see you at Hawaii.
Okay, Bob. We'll
2 plus 50 at Hawaii.
Okay, 50, and we'll be into our TLI checklist, and we'll be ready for the Pyro Arm.
Okay.
This is Apollo Control. We'll be reacquiring the spacecraft in about 18 minutes. And during that pass over Carnarvon, we passed up the numbers to the crew they'll use in the translunar injection maneuver. The burn is targeted to last 5 minutes 51 seconds with a change in velocity of some 10,359 feet per second, accelerating Apollo 17 to the required speed to get it into an orbit that'll intercept the moon. And the time of ignition, 3 hours, 12 minutes, 35 seconds. And we're showing an ejection time of 4 hours, 39 minutes. The transposition and docking maneuver, which precedes ejection, is somewhat fluid in that it's done when the crew and mission control are ready following translunar injection. However, from the projected time for ejection, it would appear that transposition and docking will occur about 25 to 30 minutes ahead of the nominal flight plan time. And we're now 39 minutes away from the scheduled ignition for translunar injection. At 2 hours, 34 minutes, this is Apollo Control, Houston.